school. Okay. Bismillahirrahmanirrahim. So we are going to start light today. Okay. Actually, this is the second section of your waves.
Okay.
We were talking about the waves that when we discussed the waves were of two types, right? It was one of the topics. So let me connect this with the previous topic. So I talked about the waves, and when I was talking about the waves were basically, you know, some sort of transverse waves, and then some of the waves were longitudinal waves. So if I talk about the waves over here, and I divide this into two parts. First, I would like to say that there will be transverse waves, okay, and second ones were longitudinal waves, right? So transverse waves were those waves, which were having the motion perpendicular to the vibration of the particles, or in which the particles of vibration were perpendicular to their motion. So in transverse waves, we have all electromagnetic waves, right? We studied this
Yes.
thing that all electromagnetic waves are transverse waves. All electromagnetic waves, first of all, this one, and secondly, I told you about water waves. Is it? So these were two waves which were basically your transverse waves, and then in longitudinal waves, we talked that they are either sound waves, okay, or the waves produced in a spring when it is moved back and forth, right? Waves
Yes.
produced in spring when moved back and forth, right? When moved back and forth. So this is what this was about longitudinal waves. So according to this, I can add two more categories over here, that the waves in spring when it is moved up and down, right? The waves in spring when moved up and down, or when vibrated up and down. So you can produce the waves in that way. And fourth one, you can produce the waves in string, vibrated up and down, or moved up and down. So this was all about uh, the waves classification. And here we are in electromagnetic waves, right? This is one of the chapters what we have to study, that electromagnetic waves are all the transverse waves, or we can say that all electromagnetic waves are transverse waves. So I can justify that electromagnetic waves are basically they are seven type of waves, right? How many waves are these electromagnetic waves? They are seven waves. Okay, how many waves they are? Seven. Can
Seven.
anybody tell me that which waves are those? Can you tell me the names?
Radio, micro,
Okay,
infra,
good.
visible, ultraviolet,
Yes.
X-ray, and gamma.
Okay, good. Hassan and Ariba, welcome you over here in the class. So I was talking about electromagnetic waves. So in electromagnetic waves, there are, as I told you, that there are seven type of waves inside, and those seven type of waves are gamma rays. Okay, the second is your X rays. There's a sequence in which I'm going to follow this. Then fourth one is your, sorry, third one is your ultraviolet. Ariba, did you ever hear these names?
Yes, sir.
Okay, so light, it is visible light. Then fifth one is your infrared, and then sixth one is your basically microwaves. ठीक है, Hassan? And what would be the seventh one? Radio waves. Okay, radio waves. So this all description tells me the light is basically a part of this electromagnetic spectrum, right? What the light is? Light is part of an electromagnetic spectrum. So that spectrum can be described in this way. I will tell you a sequence and an order. It is G, X, U, L, I, M, and R. This is actually from this point to this point. This is a increasing wavelength order, right? Increasing wavelength order. Now, very important of this all, that this is that portion what we are going to study right now. Are you people getting this thing? This is that.
Yes.
This is the light. So light is also having seven colors. One, two, three, four, five, six, and seven colors. So you know these seven colors are from violet to red. So this is what we are going to handle right now in this slide. So when I talk about the light is a form of energy, right? A form of energy. And can anybody tell me that light is a wave of a particle?
Assalamu alaikum, sir.
Walaikum salam. How are you?
Good, sir. How are you?
Fine, alhamdulillah. So light has a dual nature. Remember this thing. We will discuss about this in detail. Not its mean two natures in detail, but one of them would be discussed in our syllabus, and second will be discussed in your A levels too, inshallah. Okay, so that is a form of energy which has dual nature. Dual nature means it has a particulate nature and wave nature. Let me write wave nature first. Wave nature. I will explain it to you. Don't worry. All right. Don't get confused that oh, पता नहीं क्या पढ़ रहे हैं. So second one is the particulate nature. Particulate nature. Actually, this was that mechanism, or this was that natural happening phenomena which confused all of the scientists of the time. So wave nature, it behaves like a wave. That means this thing behaved like a wave. Okay, and secondly, it behaves like a particle. Got it? So these are two different parameters, different concepts. So, for example, if we want to say that something is having wave nature, so we have some tests for wave nature. So, what are the tests for wave nature? Those tests are, if something is performing reflection, that is a wave. If something, or if some entity is performing refraction, it is a wave. If it is performing diffraction, it is a wave. If it is having interference, it is a wave, right? So these all are tests. Okay, so light qualifies all these tests. Are you getting my words? These all are tests for wave nature. I mean, if I tell you that waves must have these properties, because I asked you the definition of waves when we started the wave. So I think Ariba told me that this is the distortion, sorry, disturbance which spreads out from the source or away from the source. Then you people added something valuable things, and then we came to the conclusion that yes, wave is that type of concept in which the particles vibrate and uh, they move away from the source. And then Yahya asked me that because light or electromagnetic waves, they do not need any medium, so how do they perform, or how do they behave like a wave without particles vibration? So these all were the questions which you people asked me in the day first, is it? सबने यही पूछे थे ना? So this is the wave test, a test for the wave nature. So whenever we are doing this all, Light basically performs this for centuries. So we can say that light is a wave. But in our syllabus, these all are included, excluding interference. This is not being discussed over here in your level. Reflection is included, refraction is included, diffraction is included. Okay, so we will discuss all of these concepts in our syllabus. Then I have a concept of particle nature. I will just give you a small detail of that, because this is a A levels 2 topic. There you people will come to know that what a particle is. Particle nature means if something is or some mechanism is behaving like a particle, it must have a momentum, right? You people are known with that. Oh yes, here one very important thing. If something is having wave, or sorry, if something is a wave, so it must have a wavelength. It must have a wavelength, simply wavelength. Okay, so all those mechanisms in which wavelength is obtained, that is called your wave. And particle हम लोग किसको कहते हैं? Which has a momentum, which has momentum. Okay, so momentum means there were some tests which were being performed. One of them was photoelectric effect. If you heard this name, कभी किसी ने नाम सुना है? Photoelectric effect. Then pair production. Okay, then Compton effect. They all are basically the tests which are, there are some other tests as well, but I did not remember their names. But these are the tests for a object which is behaving like a particle. Tests for particle. Okay, so these are not included in our syllabus. They are beyond the scope of this O level syllabus and IGCSE syllabus. So I will not discuss. Just I have given you an idea that this is basically that concept of the light. Is it? So should I move to next? So when you say that light travels in straight line, so do you people have iman at that? Huh? मानते हो
No,
इस बात में? Yes. No.
I mean,
Light travels straight.
I mean,
Right.
in a laser, yes.
Okay. So when we say that light travels straight, it means that until unless it is not affected by any other mechanism like very strong gravity or any other it may remain straight, right?
So, inertia, and
Bend, so I will show you that. Okay, so without any significant effect of three things: one, gravity; second, magnetic field; and third, it is electric field. Okay, so if these are not affecting too much, then it will travel straight. Okay, so when, for example, this is a black hole, and if I say that light travels straight, so it must pass through that. It should not be trapped inside. ठीक है, ये बात याद रखनी है. So this is what, that here we have a lot of gravity, or tremendous gravity over here. That's why light is being trapped over here. Anyhow, let's talk about our own syllabus. So when a light travels in a straight line, this is called a ray of light. Okay, what do we call it? Ray of light. Okay. Secondly, if we have combined rays, for example, we can have multiple rays over there. These can be called beam of light. Okay, what do we call it? Beam of light. right? Okay, one more thing I wanted to add. I just recalled that in particle nature, we call light as a photon of light. You people will read this word or you will hear this word in different books, a photon of light. So photon means a particle of light. So don't get confused if you are going to hear this word anywhere. So I was talking about beam of light. So beams are of three types mainly. One is parallel beam. So this is, I have drawn that, so I will write just parallel beam of light, is that one is parallel beam. Secondly, we can have a diverging beam. For example, if a light is coming out of a point, so it would cause divergence over here. So it is a diverging beam, right? What is that? It is a diverging beam, right? And if I have a light coming from any far off point and it is being focused at a single point, so it is basically your converging beam. Okay, are you people cleared in these all informations? This is your
Yes.
converging beam. Okay, अब इसके बाद क्या होता है कि we have to check that what is the speed of light in vacuum. Due to vibration of electric field and magnetic field in the universe. Electric and magnetic field, all electromagnetic waves are produced in this way. Field in universe. Because universe have these fields. So what happens when they vibrate, light travels or electromagnetic waves travel. So
सर
both of
इसको
these fields are
ऊपर करके
perpendicular.
मुझे डेफिनेशन लिखनी है थोड़ा सा ऊपर कर दें सर
ठीक है, ठीक है, याद है ये रेड वाला.
जी सर
Both are perpendicular to each other always. Both vibrations, I mean magnetic and electric field, they are perpendicular to each other. Both are perpendicular to each other and perpendicular to the direction of motion of the wave. Other and perpendicular to the direction of travel of wave, or direction of travel of light. Direction of travel of light. So this is very interesting thing, that if we have a light wave, it would behave like this. This is the direction of travel of the wave. I will draw. अभी ये मिरर थोड़ा यहाँ तक लेके आ जाऊँ, गोल्डन तक.
जी सर
Okay, so this is the direction of travel of the wave. So light travels in such a way that it has the vibration of two fields. One is the electric field, the second one is magnetic field. If this blue is electric field, then red would be magnetic field, and so on. It can be any one of them. So light has actually a light wave travels in this way. So this is it's either electric vibration or electric component. So we do not need any particle over here. Yeah, yeah. So this is its vibration of electric field. Okay, electric field, because that is available in the universe.
Okay.
So it vibrates. Okay, and this is the vibration of your magnetic field. So they are perpendicular. Check this one out. Red and blue are perpendicular to each other. So this makes the light to travel. Check this one out. They remain perpendicular to each other this way, this way. this way. They are perpendicular to each other. So here you can check this one out, that yes, they are perpendicular 90 degree, at 90 degree. They are at 90 degree. And they are at 90 degree with this direction of motion. So actually, light is a 3D wave. We do not believe this thing, but light is 3D. Check this one out. X-axis, Y-axis, and along Z-axis, it has some. For example, if I say these are the axes, so this is its Y-axis, this is its Z-axis, and X-axis is its direction of motion, right? So it is its direction of motion or direction of travel, you can say in simple words. Okay, so अब देखो, this was blue one was the electric field, and for red I can say it is a vibration of the magnetic field. So that is all about the lights. I will not drag you in more detail, because it would make a clear picture of yours in the, related to light. So the speed of light in the vacuum, can anybody tell me what is the speed of light in vacuum?
say 100
Yes,
thousand
Ariba, आप
kilometers.
बताओ. Yes, okay, Ariba.
Like the exact number?
Yes, that because that is a constant.
Um, it. I think it's like 300 million. Am I right? Meters per second.
Yes. Wow. How did you remember this big number? 300 million meters per second. So we used to write, Hassan, इसको हम लोग कैसे लिखते हैं? 300 into 10 power 6 meters per second, right? This is actually that speed of light which is over there. So if you remember, in your book it is 3.0 into 10 raised power 8 meter per second. This is constant. So it's your choice. Whatever is the easy and convenient way to remember that, it is 300, but don't mix it with 340 meter per second. 340 meter per second is the speed of, किसकी
Sound
speed है
in air.
340 meter per second?
Sound in air.
Yes, it is the speed of sound. Yes, it is sound in air. Exactly. Very good. It is not the speed of sound all the ways. This is the speed of sound in only in air. ठीक है? Is it clear to all?
Yes.
ठीक है, मैं यहाँ लिख देता हूँ कि speed of sound is 340 meters per second. Almost 1 million times slower. ऐसे ही है ना? A million times
Speed of
slower.
sound standard notation में क्या होगा?
Sorry?
Sir, the speed of
This
sound.
one?
Yes, the speed of sound. How will we write it in this form? Just आपने, I guess it's standard form, I believe. 3.0 into 10 to the power 8. This form.
हाँ, ये स्पीड ऑफ साउंड नहीं है, स्पीड ऑफ लाइट है. ये
जी सर, आई
कंफ्यूजन
नो दैट.
क्लियर
मेरी
करनी
क्योंकि हम
है.
जब
दिस
स्पीड
इज,
ऑफ साउंड इस तरह लिखेंगे तो हम किस तरह से लिखेंगे अगर हम
हाँ,
इस तरह-
अच्छा अच्छा, सॉरी, या स्पीड ऑफ साउंड इज ऑलमोस्ट, इट इज इन 100, सो नो नीड टू राइट दैट इन 10 पावर्स. ठीक है, ये बात याद रखनी. बट इफ यू वांट टू राइट, इट इज 3.4 into 10 raised power 2 meters per second. ठीक है,
All right,
बात
sir.
समझ आ रही है जी? ओके, सो दिस इज क्लियर टू ऑल ऑफ यू. इज दिस क्लियर?
Yes.
Yes.
हाँ जी, आगे चले. ओके, अब आगे चलते हैं. हसन, मैं आपसे ये पूछ रहा था कि डू यू नो व्हाट इज द सर्कमफेरेंस ऑफ द अर्थ? किसी भी बच्चे को ये पता है?
The circumference of any car. Circumference तो सर्कल का होता है.
सर्कमफेरेंस ऑफ अर्थ. हाँ,
Of Earth,
सर्कमफेरेंस ऑफ
मुझे लगा
अर्थ
car.
अगर मैं बोलूं तो व्हाट इज दैट?
नहीं पता सर.
Oh, okay. Who will tell me? Ariba?
The
Because you told
circumference
me
of the
300
Earth.
million meters, so I guess that
Sir,
yes. हाँ,
बता दूं?
Uh,
जी बताइए.
I don't exactly
40,075
remember.
kilometers.
Oh, very good, यार. 40,075. So let's say it is 40,000 kilometer. Just simply we say it. Okay. ये आपके पास क्या है? It is circumference of that. Now we can calculate that. Check this one out. I can give you a value that radius of the Earth is 6.4 into 10 raised power 6 meters. This is the value we basically now that is a constant. तो अब आप मुझे ये बताइए circumference का फार्मूला क्या होगा? Isn't it 2 by r? हाँ, तो 2 by r होगा, तो आप मल्टीप्लाई करिए. 2 into 3.142 into 6.4 into 10 raised power 6. So this will give you almost 40,000. I mean 40 into 10 raised power 6 meters. ये आपके पास circumference है. So if I tell you about this thing simply, the Earth has this much circumference. I mean, if light starts from here, it comes back to this point. It is one complete rotation. So मेरा एक question है, छोटा सा question है. How much, how many, how many revolutions or how many rotations can be taken by light around the Earth in 1 second?
Uh,
लाइट के बारे में पढ़ रहे हैं ना, तो बेसिकली आई एम नॉट in hurry to just drag you to the
7.5.
lenses and all that stuff. थोड़ा सा हम लोग पढ़ लेते हैं. Yes, how much? 7.5. Well, कैसे calculate किया? How many rotations the light can be taken by light in 1 second? In
that meter or
1 second.
kilometer?
Yeah, in meters. I mean in seconds. So if the circumference is 40 into 10 raised power 6 meters, or speed of the light, it is basically distance. Na? Circumference is kya hai? It is the distance. Is it? So light travels 300 into 10 raised power 6 meters in 1 second, right? In 1 second. So simply speaking, 300 divided by 300 into 10 raised power 6 divided by 40 into 10 raised power 6, this would be the number of rotations, the number of cycles, yeah, number of revolutions taken by the light in around the Earth. So it will give you almost 7.5. So light can round, or light can move around the Earth 7.5 times in a second. इतनी तेज है ये. Can you believe this thing? अब आप लोग light के साथ, why I am going to tell this all? Because you people have to make a comparison with the speed of light. Okay, now if I give you another comparison, then I will come back to your topic. You know where the sun is? How much, at what distance the sun is from the Earth?
150 million kilometers.
150 million kilometers. Okay, this is your Earth. This is your Earth. So from this point to that, the distance of the straight distance, that is how much? That is 150 million kilometers. 150 into 10 raised power 6 kilometers. Okay, so what is the speed of light which is released from here, or which is coming from here? Yes, Miriam, क्या होगी speed of the light from here, from the sun?
So 3 times 10 to the power 8.
Yes, 3 times 10 to the power 8. So light starts its journey from the sun with the speed of 3.0 into 10 raised power 8 meters per second. This is its speed, and how much distance it has to travel? The distance or d or s is equals to this much. So do you know which equation is used for calculation of the time? Okay, how much time will be taken for the light to travel? Ariba, can you tell me please?
I'm actually a bit confused, sir. So
Okay, no problem. Why are you confused? Is it a difficult thing to visualize, or you are having confusion in equation, or where is your confusion? That what I'm talking about? Yes.
a little bit, sir. I don't think I'm processing
Okay.
it fast enough.
Okay. Listen. Your light has started its journey from the sun with a speed of 3.0 into 10 is about 8 meter per second, and it has to travel this much distance. So my simple question is, how much time does it need? So time can be calculated by this equation, that distance is equals to speed multiplied by time, and time is equals to distance divided by speed. So please calculate this one. Distance is 150 into 10 raised power 6 into, it is actually, it that is in kilometers, so I have converted into meter. So speed is 3.0 into 10 raised power 8. So if you people have calculated, then your answer would be in
500
front of you.
seconds.
5 into
Sorry,
10.
how much?
500 seconds.
500 seconds. So if you don't mm, visualize this, then divide this 500 seconds with 60. You will come across a
And a
very
half minutes.
interesting answer. Yeah, it is 8 points.
8.333. It goes like it's a
Yes,
reciprocating one.
8.3 minutes. Now, this is very interesting fact that light has to travel for 8.3 seconds to reach to the earth. It means sun used to appear 8.3 minutes before it is seen by any person on the earth. Do you believe this thing?
I mean, light is fast, so yeah.
Yes, time taken by light travel, sorry, from sun to earth, from sun to earth is equals to 8.3 minutes. So sunset is actually 3.8 minutes, 3.8 minutes before we realize it, and sunrise is also 3.8 minutes we realize it. So there are so many things which are based on light. I can tell you so many things. For example, you know, there are so many stars and planets which are some light years away from us. So what is a light year?
A distance for light can go in a year in vacuum.
Yes, the distance traveled by a light in 1 year. Okay, so that is a distance traveled by light in 1 year. Okay, so traveled by light in 1 year. 1 year. So Ariba, I have a question with you. Don't get confused that why I'm going to take your name again and again, because I want to keep all of the students engaged. After that, Mirab will be answerable, then Hassan, and then Yahya. Okay, so be ready, all of you. Distance traveled by the light in 1 year. Can I calculate that? How much distance will it be? Distance is equals to speed of the light into time taken. Ariba, is this formula correct?
Yes, sir.
Okay, Mirab, what should I put the value of speed over here?
Sorry, sir.
What should be the speed of light for this equation?
Speed of light, wait, 3.0 into 10 to the power 8.
Okay, and Hassan, what should be the time taken?
Oh, 8 minutes and
1 year. It is basically for 1 year. We are calculating for 1 year.
अच्छा 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 ठीक
Okay,
है
ठीक हो गया? अब आप मुझे ये
Yeah.
बताइए, be ready. Yeah. In 1 year, how many days are there?
365.6.
Okay, 365. But it's fine. 365 is enough. Okay. Ariba, to convert this 365 days into hours, what I have to do?
Times 24.
Very good. Mirab, 2 minutes.
60.
Okay. And Hassan, seconds के लिए
60.
60. Very good. Now calculate this all.
9.4608 into 10 raised to the power 15.
9.46
608.
into okay 10 की पावर कितना हो गया 15
15.
yes meters. Can you believe this thing that if a person is traveling with the speed of light, so that person will travel 9.5 into 10 raised power 15 meters in 1 year. There is another fact related to that. इसको छोड़ो हम इस और एक और बात पे आते हैं. For example, बहुत इंटरेस्टिंग बात है. We are one light year away from a planet. There is another planet on the earth, sorry, in the universe. We are over here. Okay, this is earth and this is, let's say, planet X. We are how much distance away from each other? One light year. Okay, for example, we are going to have a spark over here on the earth. A big light is mm, uh, glowing on the earth, or that spark has taken place on the earth at this point, at this position. So after how much time this there is a person at planet X, he will realize that, oh, a blast have happened on the earth.
A year.
8 minutes.
Okay, yes, Ariba.
I'm honestly still thinking about it, sir.
You spotted lights towards planet X. Okay,
Okay.
you have a very big torch or very big light. Okay, you are sending a light or a laser light to planet X. You want to communicate with the avatar over there. Okay, there are some sort of creature, they can respond you on the light signal. So you are going to send a blue laser towards them. अब आप मुझे ये बताइए कि after how much time this light will reach to them, or after how much time they would be able to see your signal.
You see, sir, I don't know how to calculate it. This is
No,
where I
no
this is where I
need
get
of
stopped.
calculations. No need of calculations. The answer is in front of you. Hassan, aap batao. Then I will ask to Yaya and Mirab. You have to reframe your answer. I think
Yes.
you were able to answer, but you made just
Yeah,
hurry.
it will take 1 year. It's if it's
Sir,
one
one
light
Yes,
year
it
away,
is
it will
one
take a
year.
year.
Exactly. Obviously, that if this is one light year away, then this person sitting on the planet X, he or she or it will observe your signal after 1 year. And after 1 year, I don't know where I will be. So you know, if there is another planet, this is planet Y, and this planet is suppose 1,000 light years away from us, then the people over there, if they would be, they can see our ancient ancestors walking on the earth if they have some sort of Hubble telescopes and all that stuff. अच्छा, ये बहुत interesting बात है. ये बात समझ आ रही है? Because they will see that reflection from the earth which has happened 1,000 years back. Is this clear to all of you? This is the game of light. So why do
Yes.
we consider this concept of light is not that much topic कि हम उसको just पढ़ लें and go on. It is to think about that yeah, light, what is behavior of light, and on the basis of light reaching to us, we are claiming that universe is expanding, big bang happened, uh, universe is so much vast, this planet is made up of this gas, and this star is sorry, this planet is surrounded by this gas, and this star is formed of these gases, and so on. Light has a variety of information if you deeply study this. So that's from my side about the light. I will not go much more detail in that. Let's talk about what is included in our syllabus of the light. So as I told you that we will talk about reflection, refraction and interference, reflection, refraction and diffraction. So let's talk about reflection of light. Okay, reflection of light. Okay, the reflection of light क्या है कि bouncing back of light from opaque surfaces. Oh, I have some other points for you. Oh, should I discuss those? Light, on the basis of light, there are three types of materials, mediums: transparent mediums, translucent mediums, and then opaque. Okay, these are those they perform no reflection of light. Okay, actually, by bad luck, there is no medium which is purely transparent. So we just गुजारा चला लेते हैं कि यार okay, semi transparent is transparent. Translucent, it is partially reflecting and partially refracting. I mean, yeah, it partially reflects and partially reflects the light. Reflects and partially passes the light. Water is actually not transparent medium. It is a translucent. Your glasses, ये जो आप ऐनक पहनते हो, your glasses are not transparent. They are translucent. ठीक है? Opaque are those which do not pass the light, like your mirror, like your walls, and so on. Right? So when the bouncing back of light from an opaque surface or translucent surface, simply light from the surface of a medium barrier, whatever you call it, that is called reflection, right? So if I say that I have a mirror in front of you, this is a mirror, and believe this thing that when I draw these lines, this is non-reflecting surface of the mirror. Okay, that is your non-reflecting surface of the mirror. If I send light from a torch over here, green light, so what do you think? Will it be reflected in at this way? ऐसे ही होगा?
Uh,
If it
it
is a
should be on
torch
same
light,
degree to normal.
yes. So do you think that, or do you believe that it would be in this area, or it would be reflecting in this region?
I mean, yeah, approximately.
Approximately. Okay. So when I say that yes, the light is reflected from this surface, so it can reflect from the surface, it is bounced back, no light has passed through, right? So it is generally a reflection. So if I have a beam of light rays, for example, uh, there are so many light rays, they are going to incident over here, and definitely they will reflect in this way, then this beam, incident beam is reflected back. So usually this is what we use to observe for reflection. Ariba, is it so or not? Do you agree?
Yes, sir, I agree.
Okay, good. So reflection is of two types. Okay, one is your regular reflection. In regular reflection, actually all of the lights bounce back, our bounce back light remains parallel. So regular reflection means whenever reflection takes place, a parallel beam of light remains parallel after reflection, right? A parallel beam of light, a parallel beam of light remains parallel after reflection. Parallel after reflection. Okay, is it clear? So this is actually an example of your regular reflection. Got it? So instead of drawing this again, I'm going to show you that this is a regular reflection. And irregular reflection is that in which after reflection light diffuses, it spreads out. Irregular reflection. You know, regular reflection happens from mirrors and very smooth surfaces in which the light spreads out after reflection. Light spreads out after reflection. Okay? So actually, in our daily life, this irregular reflection takes place, and that is happening from mountains and from surfaces and from walls
इसको
and
थोड़ा
all.
scroll करें, ऊपर करें थोड़ा सा.
ये लो, ठीक है? ओके, यहाँ तक ठीक है?
जी sir.
I have a parallel beam of light. Okay, and that those parallel beam of light, parallel light rays, they reflect in different directions. Okay, it would reflect in this way. This will reflect in this way. Maybe this would be reflecting back to this way. Okay, maybe this would be reflecting back in this way. Okay, and this would reflect back to this side or this way, whatever it is. Irregular, so it is just a spreading of light. So daily life में यही होता है कि when we are having a sunshine on the mountains, ये देखो, so that light reflects from everywhere and then it comes to us as well. Otherwise, if it would be a regular reflection in the universe, only those parts can be illuminated, or only those parts will get sunshine which are directly getting the regular reflected rays. Otherwise, there are so many areas on the in the universe or even on the earth which would remain unlit from the sun. Right? So, do you believe this thing? This is called diffused reflection as well. What do we call it? Diffused reflection. बात समझ आ रही है? Should I move to next?
Yes.
Okay, so here are some laws of reflection. Here are the laws of reflection. So when we talk about laws of reflection are same as we discussed in the first lesson, that incident ray, reflected ray, because these are the rays of light. Incident ray, reflected ray, and normal to the surface lie on the same plane. This is first law. Reflected ray and normal to the surface, normal to the surface lie at same plane, lie at same plane. Okay, it means that if we have an incident ray and we have a reflected ray, and they would be incident on the same point or same position, and they would be reflected back from the same position or same plane. For example, this is a mirror, and if I say this is the normal to that mirror, almost 90 degree, I can say. Almost, it is 89 actually, but let me call it 90 because I will not be able to give that much accuracy to the 90 degree. So this is called your normal. Normal is that a line which intersect your surface or your mirror or your barrier at 90 degree. ठीक है? ये आपके पास क्या है? This is your barrier, mirror. Got it? Are you getting this thing? This is your mirror, this is your normal. I can call it N. And there will be a light which would be incident at this point. ये देखो. This is the incident ray of light, and that light ray would be reflected at the same angle at which it is being incident. Uh, Almost, I don't know at what angle it was. It was at 45 degree. Wow, what accuracy. So I have to draw at 45 degree maybe. ये देखो. So it would reflect back at this angle. So is it clear? So angle of incidence is this one. This is your incident ray. This is your incident ray, the ray which is striking on the surface, and this is your reflected ray, which is reflected back. Reflected. Why I'm going to emphasize these words? This is your reflected ray. Now, very important, very important, very important point. What is the angle of incidence? The angle between normal and incident ray is called angle of incidence. And what is angle of reflection? Angle of reflection is basically the angle between normal and reflected ray is called your angle of reflection. Don't get confused in that only these are the angle of incidence and angle of reflection, right? So angle of incidence is very important over here. Angle of incidence. What is angle of incidence or angle of incident? The angle between normal, please don't forget this, normal and incident ray. Incident ray, not from the surface. Surface के साथ angle नहीं बनाना आपने. And incident ray. Incident ray. Is it clear? So it means it is basically represented by theta I, right? What we call it, theta I, or simply in your syllabus you can write as I, no problem. Then angle of reflection क्या होता है? Angle of reflection is the angle between, yes, yeah.
Yes, sir.
What is the angle of
yeah,
reflection?
angle?
Angle
Angle
between?
between the incident ray and the normal.
Oh my God. So Hassan, can you please tell me?
Oh, God.
Yes, Hassan. Please. जल्दी बताओ शाबाश. मीरब
So
काफी
the
देर से
angle
क्वेश्चन नहीं
between
ना की.
normal and the reflected ray.
Yes, reflected ray. Yeah. No problem. Sometimes attention is lost, but I will try my best to drag you back. अब हसन नहीं पकड़ा जा रहा. हसन, where are you?
जी सर.
हाँ, तुम भी कहीं गायब हो गए थे ना?
नहीं सर, गायब नहीं हुआ था,
बस थक गया था. Yes, I know that. Okay, now let's say if I give you just the law. Okay, बस wind up करना है. The second law is, this is very important law, and reflection follows this one. Second law is that angle of incidence and angle of reflection are always equal for reflection. Angle of incidence, you have to remember that one, please. Incidence and angle of reflection are always equal. Angle of reflection are equal. If it is not, it is beyond the nature. So theta I will always be equals to theta r. Or you can say I will be always equals to r. So that's why I made this angle 45 degree, right? And this angle would be also 45 degree. Now is this clear to all of you? I'm just going to spare you people if you people will answer one of my question. And the question is very simple. Question करूं? Yes? Yeah, should I ask?
Yeah, sure.
Okay. Okay. This is the mirror. Okay. This is normal. This is your reflected ray. This is your incident ray. I have some angles W, X, Y, and Z. Okay? I have 4 angles W, X, Y, and Z. So my option A is W and X are sorry, W is angle of incidence. Let me write angle of incidence over here and angle of reflection over here. In option A, it is W, and option B, it is Y. Option B, it is W and Z, then X and Z, and then X and Y. So which option is correct?
The incident ray is X. And
No.
reflected
Angle of incidence and angle of reflection are given to you, and
Yeah,
you
angle
people
of
are asked which option is correct. A, B, C, D
Yeah.
are 4 options. This is an MCQ question. Don't underestimate your teacher
D.
that he is not an examiner. You people
Sir,
can
to
be
ask
tested
for the
anytime.
question.
Question is, Ariba, are you in the game or not?
I am, but could you please elaborate further?
Yes, I'm saying that there is a mirror, right? This is the mirror, and there is a ray, blue ray, which is going to be incidented on that mirror, and it is reflected. And I have I have indicated that this is your reflected ray. Arrows show that it is reflected, although I have not written that it is reflected. And this first one, it is incident. Okay, my question is, I provided you 4 angles W, X, Y, Z. My question is, which pair of angle of incidence and angle of reflection is correctly described?
D.
Option A, B. ये किसने बताया D? Hassan?
Yeah, नहीं.
Yeah. Okay, what's your choice then?
मेरा C या D.
C या D?
D.
Okay. Mirav, what's your choice? This is for Yahya. Okay, log one of them. C or D? Hassan?
C.
Okay. ये हसन ने कर दिया. Yes. Mirav.
Hassan.
Sorry,
Sir,
Hassan.
D.
Okay. D. Okay. And Ariba?
I also think it's D.
Majority is authority or logic is authority?
Logic is authority.
Really? Okay, Hassan, do you want to change the party?
नहीं सर, ज़्यादा से ज़्यादा क्या हो जाएगा, गलत हो जाएगा.
ज्यादा से ज्यादा क्या होगा? गोली मारेगा ना बंदा. मुझे ये बताओ, why did you select this one? C?
नहीं, ये ना पूछें.
ये ना पूछूं, चल नहीं पूछता. अब भाई मेरा explain to Hassan why did you select D?
Um, Sir, because in the previous question, you told us that the angle of incidence is basically the angle that is between the normal and the incident. So for that, it's x. And now, if we talk about the reflected angle, so it should also be the angle between the normal and the reflected ray, which is y. And he said z, but z is the angle between the mirror and the reflected ray. So that's where it's
Yes.
incorrect.
Good. Ariba, do you endorse this logical explanation?
Yes, exactly what I had to say.
Good. And Yaya, are you not with your old friend Hassan?
Not this time.
Bring him back over here, man. Yaya, why did you not help him?
सर मैं सबको चेक कर रहा था.
Oh, very good. Nice, clear man. Very good. So, ठीक हो गया? So you have to be very careful while selection of these angles. So your right option was option D. All of you won the game, Squid Game. Now you have to distribute this money amongst you people. Thank you. I'm going to give up. I'm that old man which planted that Squid Game, right? Allah Hafiz.
अल्लाह हाफिज.
Allah Hafiz, sir.
Allah
Allah Hafiz.
Hafiz. Allah Hafiz.